This lesson is on factor by grouping. We're going to take a polynomial and we're going to work backwards to find out what the two polynomials were that were multiplied to get us to just this set of polynomials that are being added and subtracted. So the first thing you're going to do is you're going to take and cut that problem in half. Draw a line right down the middle of it. And we're going to find the GCF. And if you don't know what the GCF is, you need to go back and watch the video, the previous video on finding the greatest common factor. So we're going to find the GCF of the first two terms. And I'm going to use a highlighter to kind of hopefully help make this make a little more sense. And then we're going to find the GCF of the second two terms. So when I say the first two terms and the second two terms, you just divided that problem in half. There are four things in that problem. So what we're going to do is we're going to take the first two terms. We're going to find the GCF of the first two terms. And then we're going to take the second two terms and we're going to find the GCF of the second two terms. And we're going to do that the exact same way we did it in the lesson on finding GCF. We're going to write down 7x squared plus 28x. And you can do it using prime factors, or you can do it if you recognize what the prime factor or what the GCF is right away. So I'm going to use prime factors here because 7 is a prime number. I don't have a whole lot of options. So I'm going to start with that 7. 7 gets factored out. 7x squared divided by 7 leaves x squared. And positive 28x divided by 7 leaves me with 4x. There is a variable in both terms. So I'm going to take that variable with the smallest exponent, that x, and I'm going to factor that out. So x squared divided by x leaves me with x, and 4x divided by x leaves me with 4. Then I'm going to take the second two terms, 6x plus 24, and I'm going to do the same thing. I'm going to use the prime factors here. Both even, so I'm going to divide by 2. That leaves me with 3x plus 12. 3 is a prime number, and 12 is divisible by 3, so I'm going to use 3. 3x divided by 3 is x, and 12 divided by 3 leaves me with a positive 4. So here's where you got to stop, and you got to go, okay, do these leftovers match? These leftovers, these are my leftovers, and they must match. If they don't match, or if you just write them down so that they look like they match, you're going to get the wrong answer. Now, once you've done this, you've done all of the heavy work. Now all you've got to do is actually write your final answer. So we're going to do that in 2 steps. The first part of that answer that we're going to write is we're going to take those leftovers, those matching leftovers, and the leftovers go in a set of parentheses. And when I say the leftovers, I mean the fact that these match. I'm going to say x plus 4. I'm not going to write them down twice. I'm only going to write them down as one set of parentheses. And then what I'm going to do is I'm going to take those GCFs, those things that I factored out, and I'm going to use those to make a second set of parentheses. So the GCF of both groups makes a set of parentheses. So I'm going to multiply these things back together. 7x and 6. So my second set of parentheses is going to be 7x, and this is a positive 6, so 7x plus 6. Now, if I take this and I go back and I do like we did in a previous lesson, and I multiply this set of parentheses times this set of parentheses, I should get this answer. What I've done is I've taken this polynomial and I've broken it down, and I figured out what the original problem was that got you to this point. We're working backwards at this point in time. We're trying to figure out what was the original problem. What was the thing that got multiplied together to make this? So let's practice that again. Let's do 2x squared minus 9x minus 6x plus 27. So I'm going to break my problem in half. I've got my first two terms, x is included in that, and I've got my second two terms. And I'm going to find the GCF of each of those things. So I'm going to take 2x squared minus 9x, and I'm going to find the GCF of those. 2 and 9, 2 is a prime number. 9 is not divisible by 2. So 2 and 9 don't have a GCF as numbers. But I have an x squared and an x. So I'm going to take this variable with the smallest exponent and I'm going to factor that out. 2x squared divided by x leaves me with 2x. And negative 9x divided by x leaves me with negative 9. And I'm going to do the same thing with that second half of the problem. Negative 6x plus 27. And I'm going to factor that out. So before I do that, there's something I need to point out. If a group leads, so this group leads with a negative number, you need to factor that negative out. So if either group leads with a negative, they can have a negative in the middle, but if they start off with a negative number, if they lead with a negative, you've got to factor that negative out. So you're going to make the GCF a negative number. So when I go to do this, 6 and 27 have 3 in common, but this leads with a negative, so I'm going to factor out negative 3. Negative 6x divided by negative 3 is positive 2x, and positive 27 divided by negative 3 is negative 9. Do my leftovers match? Yes. If my leftovers match, that's when I can start writing my answer. So I'm going to take my leftovers, and that's going to become the first half of my answer. And the second half of my answer is going to be those things that I factored out. So that x and that negative 3. So my second set of parentheses are x minus 3. We're taking the GCF that you've done previously and we're just making it a little bit bigger. We're looking for the two things that got multiplied together. In the lesson on GCF, there were two things that got multiplied together, but it looked more like a distributive property problem as opposed to a multiplying binomials or multiplying complex numbers. So let's do one more example. Let's do 15x squared plus 30x minus x minus 2. So we've got the first half. So we're going to factor the first half of the problem as a group, and we're going to factor the second half of the problem as a group. So 15x squared plus 30x. I'm going to go ahead and I'm going to do this with prime factors. If you see what the greatest common factor of 15 and 30 is, you can go ahead and factor that out. I'm going to do it for prime factors just for the practice. So 15 and 30 are both divisible by 5, so I'm going to start there. 15x squared divided by 5 is 3x squared. 30x divided by 5 is plus 6x. 3 and 6 are both divisible by 3. So now I have x squared plus 2x. I have an x in both places, so I'm going to factor out the one with the smallest exponent. That's going to leave me with x plus 2. Now, that second half of the problem is really tiny, negative x minus 2. And you look at that and you go, well, there's nothing in common. This is the only time that you're allowed to go, the only thing that those have in common is a 1. So the greatest common factor is 1. Most of the time in a math class, we don't say that 1 is the greatest common factor because 1 is a factor of everything. Everything can be divided by 1. But when we're factoring, we want to go ahead and say, yeah, those only have a 1 in common. Also, this leads with a negative. So not only are we going to factor out a 1, we're going to factor out a negative 1. So if there is no GCF, there's no GCF, I want you to factor out a 1 or negative 1. Kind of depends on what it leads with. This was leading with a negative, so we had to factor out a negative. So negative x divided by negative 1 makes positive x, and negative 2 divided by negative 1 makes positive 2. Look at that. It made our leftovers match. So that's part of it, is we also need to make sure that our leftovers always match. So our leftovers become the first half of our answer. And then we're going to take this, 5 times 3 times x, which is 15x. We're going to multiply those back together, and that's going to start my second set of parentheses. So 15x minus 1 is my second set of parentheses. And I could take these two things, and I could multiply them back together, and I would end up right back where I started. When we're factoring, we're trying to make that loop that says these are the things that I multiplied together to get this answer.